Pleasant day to you all, panel members, Engineer Fadriquela, Engineer Villarreal, and Engineer Balaan, to our subject teacher, Ma'am Makawile, and to our thesis advisor, Engineer Plaza. Again, a pleasant day. I am Nathaniel Dalisay, and I will be the first to speak among my group mates, Michael Joshua Tagonan and Linda Rica Plaza. To begin, our thesis is entitled Design of Turbulent Hydropower at De La Salle University das Marinas, and for my presentation, I will be discussing the background of our study and what urged us to pick this particular topic, along with the objectives of our study. As we all know, Earth's resources are limited, and as our population grows, the demand and our consumption also grow, and eventually, we will reach a point where these resources will no longer be able to meet our demands. One example of these finite resources are fossil fuels, which are the world's primary energy source. As you can see in the figure, gas, coal, and oil, these three are all fossil fuels, and they make up roughly 80% of the world's energy sources. Not only are these fuels being depleted, but they are also very polluting to the environment. Fortunately for us, we have other alternative sources of energy, such as solar energy, wind energy, and water or hydropower, which brings us to why we chose this topic. As engineers, it is our duty to develop ways to power our lives without damaging the environment and to avoid the impending depletion of our resources and find alternatives. One way we can achieve this is by utilizing hydropower. Hydropower is a clean fuel source. Electricity is generated by the flow of water, therefore there's little to no air pollution or emission of carbon dioxide. With that being said, it is an eco-friendly energy source. It is also an efficient source because it converts about 90% of energy into electricity as compared to burning fossil fuels in which only around 50% of energy is converted. It is also renewable. We all know that water goes in a cycle on Earth, so it replenishes itself naturally. These four are only a few among other countless benefits of hydropower. In relation to our country, since the Philippines is an archipelagic country composed of thousands of islands, we are surrounded by numerous bodies of water. So, me and my groupmates thought, what better alternative energy source to conduct a study on other than something we're already abundant of? We have lakes, rivers, and other bodies of water everywhere scattered throughout the country, so we decided to conduct our thesis on hydropower. For the objectives of our study, our general objective is to design a hydropower unit that will be able to provide supplemental and renewable electricity to the university, specifically the SEAT building. Aside from our general objective, we have three specific objectives. First and foremost, being to decide the conversion of water flow from a small river into electricity by turbulent hydropower. Similarly to our general objective, we aim to make the design of the hydropower unit based on our data and computations. In this part, we not only aim to determine the necessary design and dimensions of the unit, but also to determine the capacity or the power that it will be able to provide. Second objective, to determine the sustainability of the said project by applying cost analysis. For our second objective, we will determine the pros and cons of the project, as well as determine if the benefits outweigh the costs of the project. The costs of the project being direct and indirect costs, installation costs, maintenance costs, among others. We will also consider if there are other alternative materials or processes which will be much cheaper but will not sacrifice the quality or efficiency. Third objective, to analyze the proper installation of turbulent hydropower. Last but not least, we aim to learn how to properly install the hydropower unit along with the proper location placement and all the materials needed for the installation. Basically, we will take into consideration every variable needed to properly install the hydropower unit. That's it for my part. The next speaker will be Linda Rica Plaza. Thank you for listening and stay safe.
Significance of the study. First, to the school. This study will benefit De La Salle University das Marinas by introducing the utilization of a new and innovative source of renewable electricity through the use of hydropower. Next is to the environment. This research will help the environment because water is a clean fuel source that will not pollute the air like fossil fuels and coal or natural gas. Also, This will benefit future researchers who may wish to take up the same or a similar topic about hydropower. To the local government, this study would benefit local government units who may wish to utilize a similar approach in supplying energy to their locality. To the community, this study will benefit the community by giving basic backup power during significant power blackouts or disturbances. And lastly, to the future generation, this study will inspire the future generations to utilize eco-friendly sources of renewable energy. So, what are the scope and limitation of this study? This study aims on the design of a turbulent system that will produce hydropower to provide supplemental power to the LSUD. This will focus on what design is applicable in order to create a turbulent hydropower and how much generated power will be produced based on the design. The study will be conducted at the river behind DLSUD's SAYAT building, where the running water will be utilized to produce hydropower. Data such as the volume, flow of the river will be obtained by the researchers themselves by measuring the river with proper equipment. The limitation of the study includes unpredictable precipitation, which may result in excessive rainwater volume and too quick of a flow of water, too much for the turbine to handle, in which case an outlet leading behind the system will be designed to release the water and allow to pass through. The power produced will only serve as a supplement to the existing power supply of the university and not as a replacement. Chapter 2, Review of Related Literature. The first section in Chapter 2 is Damless Hydropower Plant. You can see here in the picture a sample of damless hydropower plant. So what is damless hydropower plant? Like the name itself, it's damless hydropower plant. So it is also known as run-of-the-river plants. They are thought to be ideal for energy generation for settlements near a river or stream. The second section in Chapter 2 is Turbulent Hydropower. According to one chat, this device can produce electricity from low heads, 0.7 meters to 3 meters, and can be used for mini or micro hydroelectric power plants. In developing countries, many installations were implemented worldwide because they can be regarded as an economically clean energy source without the need for fuel. The last section related to our topic is the design of turbulent hydropower. You can see here in the picture the parts of the turbulent hydropower unit. First is the thrust rack, the shaft, propeller, the inlet, the generator, the logarithmic basin, the support structure, and the draft tube. Chapter 3 will be discussed by Michael Joshua Tugonon.
So we are now in Chapter 3, Methodology. So this is our methodological framework. This research study will start from gathering data to design of turbulent hydropower. So let's discuss it all one by one. For data gathering, there are 4 data that we must consider. First is width of the river, water head of the river, and the water flow. And lastly, topography of the river. So this photo was taken in Google, so let's assume it is the small river here in Lasal beside Sayat building. So this is the cross-section area and the water velocity. So cross-section area is base times height. So we can estimate water flow rate by Q equals to A. For assessment of data, we have 4 processes to design a turbulent hydropower. First is water flow rate. So water flow rate if Q equals to AV, so the net head, so this is the net head. The net head is the green line, blue line is static pressure, and the red line is the dynamic pressure. So the net head must be located below the level of the river or the water intake, so that by the means of gravity, the water will flow to the hydropower or the powerhouse. So the formula of net head is H gross times 0.9. So third is the output of power. So how much power will it generate? So we have the formula of P times N times G times H net times N. So fourth is the hydro turbine specific speed. So for specific speed of hydro turbine, how fast will the turbine will rotate by the use of water flow is Ns equals to N times square root of Q over Hn raised to 3 over 4. So we must design also the turbine. So we have two parameters on how to design a turbine. So this is the diameter of the hub and the diameter of the runner. So after designing, we will put it on the software called ANSYS to run some tests. If there's some adjustment to improve our design, we will remodel it and run some tests again. Next is installation of turbulent hydropower. So first is excavation of inlet, outlet of the basin. Second, installing the parts of turbulent hydropower. So third is lower the turbine in the center of the basin. Fourth is putting back the excavated soil. So the last part of the installation is the opening of the river, canal, or well. So after we did this, the turbine hydropower is ready to operate. Next is budget plan. So first activity is thesis paper, item material, printing and binding. So the quantity is 1, then the unit price is 550 and 200. So the cost is still 550 and 200. Second is going to the river beside the LCD for data gathering. So fare, and the quantity is 3, unit price is 200, cost is 600. For food, quantity is 3, unit price is 250, and the cost is 750. So the total is 2,100. So next slide is chart. So first is familiarization of software. Second is the data gathering. Third is the data analysis. Fourth is the designing of hydropower unit. Fifth is simulation of river flow. And last, finalization of paper. For familiarization of software, we have start date of August 8. Days to complete is 14. Data gathering is August 8. Days to complete is 14. Data analysis is August 22. Days to complete is 14 days. Designing of hydropower unit. Start date is September 5. Days to complete is 28. Simulation of river flow. Start date is October 3. Days to complete is 28 days. And last one, finalization of power. Start date is November 1. Days to complete is 14 days. So that concludes our chapter 1 and 2 and 3. Before I end this video, we would like to thank our thesis advisor, Engineer Plaza, for giving us suggestions to improve our paper, and to our subject advisor, Mama Kawile, for helping us to finish this thesis paper, and for the panels, Engineer Fadipera, Engineer Balaan, and Engineer Villarreal. Thank you for your time. Stay safe, and God bless. Thank you.